Hi, my dear student. How are you? I know you are not well. Not only you, but also all the people of the world are passing a crying time. Actually, we never think and even imagine that these days will come before us. Okay, you must stay home and inspire others to stay home. You can save us and our nation, keeping yourself in your city. Okay, let's go. Our topics. Today I'll discuss simple harmonic motion. At first, you have to know motion and then simple harmonic motion. And what's the difference between simple harmonic motion and motion? When we apply force on a body, if the body moves, then you will get motion. This motion will be simple harmonic motion if it has some special characteristics, such as the force of the motion will be proportional its displacement and with opposite direction, and the body moves a particular point after a periodical time with the same direction. I want to say that motion will be, of course, simple harmonic motion. Do you understand? Okay. Simple harmonic motion অর্থাৎ সরল সন্ধিত স্পন্দন। সরল সন্ধিত স্পন্দন হবে এমন গতি যার উপর প্রযুক্ত বল সরণের সমানুপাতিক ও বিপরীতমুখী এবং একটা নির্দিষ্ট বিন্দুকে পর্যায়ক্রমে একই দিক থেকে পরিভ্রমণ করে। Do you understand? Okay. Now I have to know that where we can apply simple harmonic motion. We can apply simple harmonic motion in simple pendulum, moving spring, and in molecular physics. Today I will discuss simple harmonic motion on the field of simple pendulum. Okay, now we have to draw a simple pendulum. So very easy. It's a simple pendulum. It's called ball, as mass, and this point is equilibrium point. Okay. When you apply force on the bob, at first bob will receive this force. This receiving force will be called restoring force. By this restoring force, the bob will be oscillated left and right. The bob can easily move left and right. Okay. And you can find distance. Suppose a moment bob come here, and you can find distance from equilibrium point, and this distance will be called displacement, mane সরণ. You can find very much displacement because the more force you will apply on the bob, the more displacement you will get, as per the Hooke's law that you have already learned previous chapter. Clear? Okay. When you get maximum displacement will be called amplitude. Do you know? অর্থাৎ সর্বোচ্চ সরণকে বিস্তার বলে। তো যখন তুমি সর্বোচ্চ সরণ পাবে তখন এটা বিস্তারের সমান হবে না? Obviously it will be amplitude when you get maximum displacement. When you get maximum displacement, that time the bob's velocity will be 0. Okay, because bob this maximum point, when bob comes this point, the restraining force run off totally, and bob stay here for a moment. For this reason the velocity will be 0. Okay, now we'll explain in mathematically. As per the definition of simple harmonic motion, we can write F is proportional minus x. X is displacement and F is force, that means restraining force. Or F equal to minus kx. K is a constant, it's called spring constant. Or F equal to ma, we know from Newton's second law, minus kx. Or A equal to minus k by m x. M, the mass of the bob, also a constant. K is a constant, so k by m will be a constant. We know k by m equal to omega square. Omega, angular velocity, you know, also a constant. So can write omega equal to k by m. Omega equal to k by m, it's another rules you have to apply when you solve your problems included in your books. Okay, and write A equal to minus omega square x, and F acceleration, we know A equal to dv by dt, and v the velocity, or we can write v equal to dx by dt. Then we can finally write A equal to d dt into dx by dt, or A equal to d square x by dt square. Okay, we can write d square x by dt square instead of A. And d square x by dt square plus omega square x equal to 0. It's a differential equation of simple harmonic motion. And now we have to solve this equation. If I want to solve this equation, we have to multiply by 2 dx by dt in both sides. Means 2 dx by dt into d square x by dt square plus 2 dx by dt into omega square x equal to 0. And we have to simplify this equation for d dt dx by dt square plus d dt omega x square equal to 0. It may be difficult to you, but it's not difficult. It's very simple. Actually, if you can divide, if you want to know or you can understand this line, you have to understand the differential equation, that means differentiation. You have to know the rules of differentiation. If I differentiate this, you can easily get this line. Okay. Or d dt dx dt whole square plus omega x square equal to 0. And this time I have to differentiate this equation. No, differential not. We have to integrate this equation. Integrate d dx by dt whole square plus omega x square equal to 0. What are the rules that if we integrate dx, will get x plus c. So integration dx will get x plus c. That means x plus c. See, that means constant. Or dx by dt square plus omega square x square equal to c. It's an integral constant. I have to find out the value c. We know when displacement will be the amplitude. That means when displacement will be equal to amplitude, then velocity will be 0. When x equal to a, then v equal to 0. That means velocity will be 0. We can write dx by dt instead of v equal to 0. Now x equal to a and dx by dt equal to 0. I have to put in equation 1, and then I will get the value of c. Okay, 0 square plus omega square a square equal to c, or c equal to omega square a square. Now we have to put c equal to omega square a square in equation 1. From 1 equation, get dx by dt square plus omega square x square equal to omega square a square, or dx by dt square equal to omega square a square minus x square, and dx by dt equal to plus minus omega square root over a square x square. Now we can take positive sign or negative sign. At first we will take positive sign and then negative. Okay, dx by dt equal to omega a square minus x square, or dx over a square minus x square equal to omega d2. That time we have to again integrate this equation. Actually, you have to know this equation. You can memorize these rules and you can solve all the problems included in your books. But if you don't understand the topics, you will never can solve all the problems. So you have to at first understand your topics and then you can apply or you can solve your problems. Okay, if you don't understand your theory, you will never apply in your so I want to say that you will never overcome in future when you will face some problems. Okay, I have to integrate this dx a square minus x square equal to omega integration dt. We know as per the rules of integration dx by root over a square minus x square equal to sin inverse x by a. So sin inverse x by a equal to omega, and we know the integration dx equal to x. So at that point integration dt will be t and a constant. That time we will take constant delta because we have already taken c, and this time we will take delta. Delta has another name, it is also an integral constant and it has another name, that means phase difference. Okay, x by a equal to sin omega t plus del, or x equal to a sin omega t plus del. It's a equation of displacement. If we took negative sign, we would get x equal to a cos omega t plus del. Okay, you can solve it at home. Now, by using this equation, we can find out the equation of velocity, the equation of acceleration, and this equation we can apply to solve our problems. And now we'll find the equation of velocity. Okay, we know velocity v equal to dx by dt. We can write ddt a sin omega t plus del, a sin omega t plus del instead of x, and I have to differentiate a. If I differentiate sin theta, we will get cos theta. cos omega t plus del, and we'll differentiate omega t plus del. We get omega, because you know that as per the rules of differentiation, it means যখন তুমি কোনো একটা ফাংশনকে ডিফারেন্সিয়েশন করবে কোনো একটা নির্দিষ্ট চলকের সাহায্যে, তখন ওই চলককে ডিফারেন্সিয়েশন করতে পারবে এবং বাকি চলকগুলা যদি সিঙ্গেল থাকে তখন সেটা কনস্ট্যান্ট হবে। কিন্তু যদি সিঙ্গেল না থাকে, সহগ হিসেবে থাকে, তখন এগুলা ধ্রুব হিসেবে রয়ে যাবে। এখানে ওমেগা টি, ওমেগা কনস্ট্যান্ট, কিন্তু এখানে সহগ হিসেবে রয়েছে বলে রয়ে গেছে, টি করলে এক হয়েছে। আর ডেল ধ্রুবক, এর সাথে কোনো চলক নাই, তাই আমরা ইন্টিগ্রেশন করতে বা ডিফারেন্সিয়েশন করতে পারি না। ওকে, ক্যান ইউ আন্ডারস্ট্যান্ড? লেটস গো। V equal to A omega. We can write square root over 1 minus sin square omega t plus del instead of cos omega t plus del. How well? Can I explain? We know sin square theta plus cos square theta equal to 1, or cos square theta equal to 1 minus sin square theta, or cos theta equal to square root over 1 minus sin square theta. I can write using this rule. Okay, and next d, that means d equal to a omega square root over 1 minus, can write x square by a square instead of sin square omega t plus del, because we know x equal to a sin omega t plus del, or x by a equal to sin omega t plus del. Do you understand? So I can write x square by a square instead of sin square omega t plus del. I will get x square by a square if I square this equation. And now I can write b equal to a omega a square minus square, or b equal to omega square root over a square minus x square, as the equation of velocity. And now you can find thus the equation of acceleration. Well, now acceleration a equal to dv by dt, or ddt, we can write dx by dt instead of v. ddt we know x equal to a sin omega t plus del, a sin omega t plus del, and we have to differentiate a equal to ddt. If I differentiate it, you can get a omega cos omega t plus del. Action it few minutes ago. So you can understand easily. And now this time a omega constant. If I differentiate cos theta, we will get minus sin theta. Minus sin omega t plus del and a omega. Now we can write minus omega square a sin omega t plus del. We can write minus omega square x instead of a sin omega t plus del, because x equal to a sin omega t plus del. Is the equation of acceleration of simple harmonic motion. These four relations, that means omega equal to square root over k by m, and the equation of displacement and velocity and acceleration. These four equations will be very important when you will go to solve your problems included in your books. Okay, keep in mind, if you don't understand, you will of course call me or my senior teachers. They will help you very much, a lot. And no, today actually I'm not expert on this, but it was my effort only. Bye bye.